रयत शिक्षण संस्था यशवंतराव चव्हाण Institute of Science, Satara, Autonomous Department of Nanoscience and Technology. I am Miss Power Prajakta, working as an assistant professor in Nanoscience and Technology Department. Now we start the unit Amine and Diazonium salts. First of all, we introduce the amines. What is the amines? The amines are a nitrogenous compound containing basic functional group of a nitrogen atom with a lone pair. Amines is also derivative of ammonia, whereas a one or more hydrogen atom replaced by an alkyl and aryl substituent group respectively called as a alkyl amine and aryl amines. Amines in which both types of substituent are attached to the one nitrogen atom may be called as a alkyl aryl amines. Also, the substituent of NH2 is called as a amino group, compound with a nitrogen atom attached to the carbonyl group, thus having the structure RCO and R dash, R double dash are called as amide. Amide has a functional group and have a different chemical properties. Now we start the classification of amines. Amine can be classified according to the nature and number of substituent present on a nitrogen atom. First of all, aliphatic amines commonly contain only hydrogen and alkyl substituent. Also, aromatic amines have a nitrogen atom connect to the aromatic ring. These are the examples of alkyl amine and aryl amine. RNH2, that is the alkyl amine, and benzene ring containing the NH2 group or amino group called as aryl amine. Amines are organized into the three subcategories based on the number of carbon atom adjacent to the nitrogen atom. First of all, ammonia. We know the ammonia is a derivative of amines. So, first is a primary amine. Primary amines arises when one of the three hydrogen atom in ammonia replaced by the alkyl or aromatic group. This is known as a primary amines. The NH2 is a amino group. So we attach to the NH2 group. That some examples of the primary amines is the methyl amine, methyl amine, methyl amine. First of all, the primary amine. This is a structure of primary amine RNH2 with a lone pair. Then second part, secondary amines. Secondary amines have a two organic substituent, either alkyl, aryl, or both substituent present on a nitrogen atom with the replaced two hydrogen atoms. That is the bivalent NH group is called as a imino group. Some examples of the secondary amines is a dimethyl amine and diphenylamine, NHCH3, CH3, phenyl ring, NH phenyl ring. Then now we move to the tertiary amine. Tertiary amine is a nitrogen has the organic substituent, that is the example of trimethylamine or EDTA. Trimethylamine CH3 thrice N. And fourth subcategory is determined by the connectivity of substituent attached to the nitrogen atom, that is the cyclic amine. Cyclic amines are either secondary or tertiary, not primary amine. Examples of cyclic amines for the 3-member ring is a aziridine and the 6-member ring is a piperidine. Then tertiary amine, cyclic tertiary amines, example is a N-methyl piperidine. Some examples shown in figure. The quaternary ammonium cation or its salts with the maybe kinds of anion carries positively charged nitrogen center linked to the 4 substituent. They are not a basic but related to the amines. Now we move to the nomenclature. Nomenclature part 1, systematic or common name and IUPAC name. First of all, we introduce the common name. Common name of amines typically bears a suffix amine, name of radical attached to the N. Also indicate the presence of 2 or more organic compound present in amines. So we prefix the di, tri, etc. Now move to the second part, IUPAC system and the IUPAC system nomenclature. So in IUPAC system ending letter E of the alkane is replaced by amine. So generate the first of all alkana amine. Okay, then example of primary amines, methyl amine. Methyl amine converted into the nomenclature by the IUPAC system, metha amine. Another example, ethyl amine. Ethyl amine is a common name and move to the IUPAC system is a ethamine. Also, third example is a isopentyl amine. IUPAC system name is a 2-pentaamine. Then secondary amines. Secondary amines means example of secondary amines is a diethylamine. In IUPAC system, it is a ethanoamine. Okay, now we move to the tertiary amine. Tertiary amine, example of common example in tertiary amine, triethylamine, and IUPAC system name is a N-dimethylamine. Also, aromatic amine, nomenclature for the aromatic amines. First example is a aniline. Aniline is a common name, and IUPAC nomenclature is a benzoamine. Then second example, N-methyl aniline. It is a common name. So IUPAC name is a N-methyl benzoamine. And another third example is a P-toluidine. IUPAC nomenclature is a 4-methyl benzoamine. Amines with a multiple amino group are called as a diamines, triamines, tetramines, and so on. Then now we introduce the structure of amine. Okay, alkyl amines carries tetrahedral nitrogen center. The bond between carbon, nitrogen, carbon, and carbon, nitrogen, hydrogen. That is the angle approach is a value 109, and then the carbon nitrogen bond length. We introduce the carbon nitrogen bond length is a slightly shorter than carbon carbon bond. Energy barrier for the nitrogen is an inversion of stereocenters is about 7 kilocalorie per mole. Example is a trialkyl amine. In shown in this figure, NHCH3CH3. Bond angle between carbon, nitrogen, carbon is a 109. Also, bond angle between carbon, nitrogen, hydrogen is a 109. Nitrogen has a 5 valence electron, and so it's a trivalent with a lone pair. According to the Y.C.I.S.Satara theory, nitrogen present in amine is a sp3 hybridization, and due to the presence of lone pair. It is a pyramidal in a shape instead of the tetrahedral shape, which is a general structure of most sp3 hybridized molecule. Each of the 3 sp3 hybridized orbitals of nitrogen overlap with the orbital of hydrogen or carbon depend upon their configuration of amine. Due to the presence of lone pair, carbon-nitrogen-hydrogen angle in amine less than 109 degree, which is characteristics of angle of a tetrahedral geometry. Also, amine of type of NHR, R' and NRR double dash, that is the secondary and tertiary amine, can be chiral as a nitrogen center, bear 4 substituent counting a lone pair, because the low energy barrier into the inversion. Then in aromatic amines, nitrogen is often nearly planar due to the conjugation of the lone pair with aryl substituent. In a carbon nitrogen distance is corresponding to the shorter. In aniline, carbon nitrogen length is the same as a carbon carbon bond. Then we next point, method of preparation. A variety of method are available to prepare amine. Some selected are discussed. First is a alkyl halide by aminolysis. Second is Gabriel phthalimide synthesis, and third one is a Hofmann bromide reaction. First, from the alkyl halide by the aminolysis. In these reactions, the alkyl or benzene amine are directly obtained by the heating alkyl or benzyl halide with the ethanolic solution of ammonia at 373 Kelvin in Cl2. This reaction called as a aminolysis replaced by the halo group X- with the amino group breaking with a carbon and halide bond, breaking of CX bonds, also known as the CX bonds. The first reaction is shown in figure. Rx in presence of ammonia, ethanolic solution of ammonia at 373 Kelvin. Then convert to the RNH alkyl halide to give a product RNH3X. In this reaction, ammonia bind with the R group and the break with the R and X bond. Then add excess amount of ammonia at a 373 Kelvin. We gives the primary amine plus NH4X is a removed byproduct. This is a nucleophilic substitution reactions where is ammonia act as a nucleophile and primary amine is formed in a first step. For the reactions, alkyl halide of secondary amine. Further, we add the alkyl halide in primary amine to give secondary amine. For the reaction, we added more alkyl halide to give secondary amine to the tertiary amine. Then further we react alkyl halide with the tertiary amine, we give the quaternary ammonium salt. This reaction of ammonia with alkyl halides leads to the form primary amine. This is a reaction. This is a primary amine RNH2 in presence of added or in presence of alkyl halide, we give secondary amine. We added some amount of alkyl halide in secondary amine, we use tertiary amine. In third step, we added some amount of alkyl halide, we use quaternary salt. The composition of the final mixtures depends on the molar ratio. That is the molar ratio of alkyl halide and ammonia used for the reactions. If we alkyl halide is excess, with the major product is a quaternary ammonium salt. If ethanolic ammonia is excess, the major product is a primary amine. The reactivity order, we show the reactivity order for the halides. R iodide or alkyl iodide is a greater reactivity than the alkyl bromide than alkyl halide, and then the some reactions of alkylation of ammonia. Then most of the reactions have a limitations of aminolysis. We see the limitations of aminolysis. First is the alkylation of ammonia is often selectively and inefficient as a aminolysis for alkyl halide does not give a single amide, but we give a mixture of primary, secondary, tertiary amines. Also, second limitation is aminolysis is not suitable for preparing aryl amine because of the low reactivity of aryl halide nucleophilic substitution. This is the first reaction. Now we move to the second reaction for the unsubstituted amide, that is a Hofmann degradation or Hofmann reaction. Hofmann rearrangement reaction of primary amide to give primary amine. Okay, in this reaction, we react primary amide with halide and base to give primary amine. Okay, then the reaction is a RCONH2 plus X2 plus 4 molecule of base, that is the NaOH. We give the secondary primary amine plus 2NX plus Na2CO3 plus 2H2O molecule as a byproduct. In these reactions, we react with the amide to form alkyl halide and base. Next, from the phthalimide, Gabriel synthesis. In Gabriel synthesis, phthalic anhydride reacts with ammonia. It gives phthalimide, and then phthalimide reacts with the aqueous solution or alcoholic solution of KOH. It gives potassium phthalimide. In Gabriel synthesis, potassium phthalimide is react with the alkyl halide to produce N-substituted phthalimide, and the N-alkyl phthalimide can be hydrolyzed by the aqueous acid or base to give a primary amine. Then this is a reaction for potassium phthalimide. First of all, phthalic anhydride reacts with ammonia, and we give phthalimide, and then phthalimide reacts with a KOH. So we give directly potassium phthalimide in presence of alkyl halide. We use N-ethyl phthalimide. In ethyl phthalimide hydrolysis by or acid or base, we use sodium phthalate and primary amine. This is a mechanism. This is a potassium phthalimide. This is a phthalimide in presence of KOH. We give potassium phthalimide. Then nitrogen lone pair attacks on a R group. Then X is a good leaving group, leave out. We give an phthalimide. Then N-phthalimide or N-alkyl phthalimide hydrolysis by H2O or acidic medium H3O plus. We give sodium phthalate and primary amine. Third one is a Gabriel synthesis. Gabriel synthesis is in Gabriel synthesis, yield only primary amine, cannot form a secondary and tertiary amine. Also, in a phthalimide reaction, we gives only primary amine, not gives a secondary and tertiary amine. Then we move to the Gabriel synthesis. Gabriel synthesis. In a Gabriel synthesis, aniline cannot be prepared by Gabriel synthesis. The aryl halide do not nucleophilic substitution. So there is a no prepare of aniline. Then the reaction. The reaction of amines are due to the amino functions. First reaction is a carbyl amine reaction. In a carbyl amine reactions, the primary amine when heated with a chloroform and solution of potassium hydroxide to give a isocyanide. Then secondary and tertiary amine do not give this reaction. So this reaction serves as a test for the distinguish to the primary amine from secondary and tertiary. In a carbyl reaction, carbyl amine synthesis, first reaction is a RNH2 plus CHCl3 plus KOH. That is the primary amine, and that is the in presence of chloroform and potassium hydroxide. In presence of heat, we give cyanide plus 3 molecule of KCl plus 3 molecule of H2O. This is a mechanism. We use a base for the abstraction of proton. Base OH minus abstract the proton from the chloroform. We give CCl3 and remove from the H2O. So then next step, we form the dichlorocarbon because of remove of Cl minus, and we use dichlorocarbon. This dichlorocarbon reacts with aniline, primary amine. Nitrogen in a primary amines, the nitrogen have a lone pair, and this lone pair attacks on a carbon atom from the dichlorocarbon. Then once then bind with a nitrogen and carbon, new bond form, and nitrogen have a positive charge because of the sharing of electrons to the carbon. Then in the next step, nitrogen have an instability. So we remove the or deprotonate one hydrogen present on a nitrogen atom. Then they stabilize the nitrogen atom. Then nitrogen have a one lone pair in the next step. They generate the second double bond from the nitrogen and carbon. So remove the one chlorine atom, and we get a RNH double bond CH single bond chlorine. In a third step, another nitrogen have a positive charge because of the sharing of electron to the carbon and generate the double bond. So in the next step, we remove the hydrogen present on the nitrogen atom. Then nitrogen stabilize. Nitrogen have a one lone pair, having one lone pair. This lone pair also generate triple bond with a carbon and one Cl removed from this compound. Then in the next step, nitrogen have a positive charge and carbon attached. We stabilize the positive charge from the adding a base abstract to more acidic proton present on carbon atom. Then this hydrogen atom remove from the base, and the carbon and hydrogen bond break. These electrons migrate to the carbon atom. Carbon atom have a negative charge, and we form the R and triple bond C plus H2O molecule. That is the isocyanide. Then aniline, another example, aniline plus chloroform plus 3 molecule of KOH, we give phenyl isonitrile compound. Okay, thank you.